Welcome to The Deep Dive. We're the podcast where we take a whole stack of sources and pull out the key insights just for you. Today, we're jumping into a story that's, well, really fundamental to ocean health. It's a story of collapse, but also, surprisingly, of hope. Try and picture this for a second. These huge, shimmering underwater forests, kelp forests, giant golden fronds just swaying, sunlight filtering down. People call them the sequoias of the ocean.
That's a great analogy. They really are foundational.
Absolutely. They're these massive ecological engines, right? Providing food, shelter, refuge for so many species.
Fish, seabirds, otters, sea lions.
Oh,
The list goes on.
and they do so much more, driving nutrient cycles, protecting coastlines from waves, even sucking up carbon.
Yeah, they're crucial. And culturally, economically, too, for coastal communities. They support fisheries, tourism.
They're the bedrock, really. But then, about a decade ago, something silent and deadly appeared.
A silent killer, yeah.
So our mission in this deep dive is to unpack that mystery. What threatened these vital forests? What was the surprising culprit? We'll look at the ecological fallout, the ripple effects, and now this really inspiring path towards recovery. Think of this as your shortcut to getting up to speed on something critical. It's all about fragility, resilience.
And interconnectedness, that's the key theme here, I think. How fragile these systems can be when one piece is removed, but also how resilient they can be if we understand the problem and, work together. And the main character in this whole drama, it's the magnificent sunflower sea star.
Ah, yes, Pycnopodia helianthoids. What an amazing creature. Before all this happened, what made it so vital? Why was it like a keystone?
Well, you have to picture it first. This thing can be huge, like a meter across.
Wow.
Yeah, with up to 24 arms. They move surprisingly fast for a sea star. Before 2013, they were everywhere along the Pacific coast, Mexico to Alaska. A really dominant predator.
A predator? What were they eating?
They were basically the gardeners, keeping everything in balance. They especially loved eating purple sea urchins.
Ah, okay.
By keeping those urchin numbers down, they allowed the kelp forests to thrive, creating that whole habitat we were just talking about.
So these multi-armed guardians were patrolling the kelp. But then, 2013, things went south, fast. Can you describe what started happening? What did this wasting disease actually look like?
Oh, it was grim.
Yeah.
Really gruesome. Scientists started seeing stars develop lesions, white spots on their bodies. Then their tissues would just start to break down, decompose.
While they were still alive.
Yes. And horrifically, their arms would literally detach, just fall off.
Oh, God.
Until the whole star basically disintegrated into this pile of, white goo, sometimes in just days or even hours.
That sounds like something out of a horror movie.
It really was, and it was happening up and down the coast, thousands of miles, a slow-motion ecological disaster.
And the scale. This wasn't just a few isolated incidents, was it?
No, not at all. It became known as the largest marine epidemic ever recorded in the wild. That's how bad it was.
How much of the population was lost?
Overall, across their entire range, the population crashed by more than 97%.
97%.
Yeah. In some specific areas, it was 100%. They just vanished. Gone.
And that kind of loss, it must have had immediate knock-on effects.
Absolutely. It triggered what's called an ecological cascade, a domino effect. With the main predator of urchins gone, the kelp forests themselves were suddenly in serious trouble.
So this massive die-off happens, but for years, nobody knew exactly why, right? The cause was a mystery.
It was a huge enigma. It took over a decade to really nail it down.
What were the initial suspects?
Scientists considered a lot of things, maybe new virus, environmental stress, like warming waters definitely played a role,
Yeah.
pollution maybe. But proving a direct link to one specific pathogen was incredibly difficult.
Why so hard?
Well, think about it. The ocean is teeming with microbes. Isolating the one specific killer in that soup and then proving it caused this disease across such a vast area. It's like finding a needle in a global haystack.
Plus the speed of it all.
Exactly. By the time researchers got samples, often the sea stars were too far gone or already decomposed.
A massive challenge. But finally, a breakthrough in 2025. A collaboration between several institutions.
That's right. University of British Columbia, the Hawkeye Institute, University of Washington. Pooling resources and expertise. Persistence paid off.
And they found the culprit?
They did. They unmasked it. A specific strain of bacteria called Vibrio pectinacida, FHCF3.
Vibrio. That genus sounds familiar. Isn't that related to?
Cholera, yes. Vibrio cholerae causes cholera in humans.
Okay, so it's a known troublemaker genus.
Exactly. Not all Vibrio are bad, but this group certainly contains some serious pathogens, and this particular strain was definitively linked to the wasting. It basically turns the sea star's own body against itself.
And the link to climate change here seems really significant. This wasn't just bad luck.
No, that's the really alarming part. The research showed this bacteria, Vibrio pectinacida, thrives in warmer water.
Ah.
So in an era of warming oceans and more frequent marine heat waves, you see the problem.
It's a double whammy.
Precisely. The sea stars are already stressed by the heat, which probably weakens their immune systems. Then, this pathogen that likes the heat hits them when they're vulnerable.
Makes sense.
Dr. Melanie Prentice, one of the lead researchers, said they saw the disease appearing earlier and spreading faster in warmer waters. It's a really stark warning.
A preview of what climate change can unleash beyond just heat stress.
Yeah, it's unlocking new diseases, new threats.
So the sunflower sea star vanishes, leaves this huge gap, this vacuum in the ecosystem. And you mentioned earlier, the purple sea urchins are the main kelp grazers.
Right. And without their number one predator around,
Their populations must have exploded.
exploded is an understatement. They multiplied unchecked, leading to this phenomenon called urchin barrens.
Urchin barrens. What does that look like?
Imagine those lush, vibrant kelp forests we talked about. Gone. Replaced by bare rock, just carpeted with spiny purple sea urchins. Millions of them.
Just urchins, nothing else.
Pretty much.
Wow.
In some places, the density of urchins shot up to more than 60 times what it used to be.
60 times. Wow.
Yeah. They just ate everything. It's a classic trophic cascade. Remove the top predator, and the whole system unravels downwards.
Is it fair to say that urchins are the villains here? Or is it more complex?
It's more complex. Urchins are a natural part of the system. In normal numbers, their grazing is fine, even healthy.
Right.
But when their predators disappear and their numbers boom like that, they become, well, destructive. They transform the environment into something completely different, a biological desert almost.
And the impact wasn't just on the kelp, was it? This cascaded further.
Oh, absolutely.
Yeah.
Think about everything that depends on kelp. Abalone lost their food source. Rockfish lost their nursery grounds and hunting areas. Commercial fisheries dependent on kelp-associated species were hit hard. Urchin fisheries themselves, actually, because the urchins and barrens are often starving and low quality. Other fishers, their livelihoods were directly impacted.
And the impact on indigenous communities.
Profound and often overlooked. For countless generations, their culture, traditions, food security, it's all interwoven with the health of these coastal ecosystems. Losing access to traditional harvesting grounds, seeing these places transformed, it's a deep cultural loss, too.
Such widespread devastation. But now, knowing the killer, Vibrio, there's a sense of hope returning.
There really is. Identifying the cause was absolutely critical. It allows for targeted strategies.
And there's a big collaborative effort now, right? This working group.
Yes, the Pycnopodia Recovery Working Group.
Yeah.
Its impressive spans 3 countries, multiple U.S. states, scientists, managers, conservation groups, all working together.
What's their plan? What's the blueprint for recovery?
It's really multi-pronged. First, they need to fully understand the disease itself, how it works, how it spreads, especially with changing ocean conditions. Prepare for the future. Second, actively rebuild the sunflower sea star populations. And third, help restore balance to the kelp forests that were so damaged. It has to be holistic.
And a big step happened just last year, 2024, the release of captive-bred stars.
That was a huge moment. 20 young sunflower sea stars, raised carefully in labs, were released back into the wild near San Juan Island.
Must have been nerve-wracking.
Oh, absolutely. It's a crucial first step, a real symbol of hope. Proof of concept, really.
But just the start of a very long road, I imagine.
Definitely. Raising them in captivity is complex. Releasing them successfully, monitoring them, it's intensive work. But each release teaches us more, helps refine the process for larger efforts. It's a beacon.
So bringing back the stars is key, but you also mentioned restoring balance. That involves dealing with the urchins, too.
Yes, absolutely critical. You can't just put the predators back into a system that's still overwhelmed by grazers. The stars need help initially.
So direct intervention, people removing urchins.
Exactly. We're seeing dedicated urchin removal projects. Divers, often in places like California or even Tasmania where they have similar issues, are physically going down and removing urchins by hand.
That sounds incredibly labor-intensive.
It is. Painstaking work. Clearing specific areas to give the kelp a chance to regrow. It's like weeding a garden that's been completely overrun.
And what happens when you combine those efforts? Removing urchins and reintroducing sea stars, even in small numbers.
That's where the magic happens, potentially. Studies are showing a really positive synergistic effect. Even a small increase in sunflower sea stars in an area where urchins have been manually reduced can help keep those urchin numbers down long term. They maintain the balance.
So the stars help prevent the barrens from reforming.
Precisely. And interestingly, the stars aren't picky. They'll eat starving urchins from a barren just as readily as healthy ones, which means they can actually help reset the ecosystem naturally once we give them that initial leg up. It really shows the power of restoring those predator-prey dynamics.
Okay, so the path forward seems clear but complex. It needs multiple things happening at once.
That's the key takeaway. It has to be multifaceted and sustained.
So what are the big action items?
Well, first, expand the captive breeding and reintroduction of the sea stars. Scale that up based on what we're learning. Second, continue and maybe even expand the direct management of urchin populations in those barren areas. Tactical removal where needed.
Makes sense.
Third, really push the research forward. We need to know more about the disease dynamics, especially with climate change. And also, look into kelp genetics. Are there more resilient strains we could encourage?
Future-proofing, basically.
Exactly. Building resilience against climate change impacts has to be part of it. Understanding future vulnerabilities, and the absolute linchpin for all of this.
Yeah.
Collaborate
Across the board.
across the board. Scientists, governments, indigenous communities who hold vital traditional knowledge, nonprofits, fishers, the public. Everyone needs to be involved. It's a shared problem, needs shared solutions.
It really underscores that this isn't just about saving one cool-looking sea star.
Not at all.
It's about the health of entire ocean ecosystems, systems that ultimately support us too. The link between that tiny bacterium and our own well-being via the kelp forest is surprisingly direct.
It really is.
This whole story, this deep dive, it's just incredible. A real testament to how fragile life in the ocean can be, but also how resilient it can become.
It truly is both. Fragility and resilience side by side.
It definitely makes you pause and think about interconnectedness.
And that's the thought I'd like to leave people with, really. We started this conversation talking about a disease hitting one species in one part of the world. But what does the story of the sunflower sea star really teach us about how deeply connected everything is in our oceans, maybe even on the whole planet, and how our actions, or sometimes our inactions, can ripple through these incredibly complex systems in ways we might not expect or even see until it's almost too late?
That's a powerful question to reflect on. We really encourage you, our listeners, to keep exploring this. Think about your own connection to the oceans because, as we've heard today, their future, and maybe ours too, really depends on understanding and protecting these vital connections.